All right, let's take a look at what the proof of this might look like. So we're going to prove that if f of x is equal to x to the n, then f prime of x is equal to n times x to the n minus 1. This is our power rule. And so our proof is going to have to start with the definition of the derivative. So we'll say f prime of x is equal to the limit as h goes to 0 of x plus h to the nth power minus x to the nth power all over h, which looks innocuous enough until we realize we have to expand x plus h to the n power. This is where we have to go back and remember what our Pascal's triangle was all about. So let's get Pascal's triangle on here and see what that can help us do. Okay, and it's moved basically by patterns here, right? We know that if it was x plus h to the fourth power, that would be talking about this line. And so, for example, x plus h to the fourth, according to that, would be 1x to the fourth plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the fourth. Okay. And so we can at least get started on this a little bit and say this is equal to the limit as h goes to 0 of, well, I know it's going to start with an x to the n. And then what do I know next? I know that my next term is going to have an x to the n minus 1 times h in it. But how many of those am I going to have? Well, if I look down here, I know that the first coefficient is always going to be 1. The second coefficient was a 4 here, and if I look at where my second coefficients come from, okay, well, if I'm to the fourth power, it's the second number in, and it's a 4. If it was to the fourth power, to the fifth power, it's going to be a 5. So in general, to the nth power, that's going to be an n in front of there. Okay. And then, of course, I'm going to have something with an n minus 2 times an h squared and a bunch of other stuff in there. Okay. That I'm just going to kind of gloss over at this point, all of the other stuff, because I know that it's going to end with an n times x times h to the n minus 1 plus an h to the n minus x to the n, and that is all over h. Okay, so we may be a little bit worried about all that stuff that I skipped in the middle, but what we notice certainly is that I've got an x to the n there and a minus x to the n there, and everything else that's left in the numerator has an h in it. So this is my limit. As h goes to 0, I can factor an h out of everything up there, and I'll be left here with this first term as n times x to the n minus 1 plus this next one in there. I don't know exactly what the coefficient was. I know it was an x to the n minus 2, but I know it also used to have an x or an h squared in it, so it still has an h. In fact, everything that's left up there is going to have h's in it. Stuff with h's up there over h. And so as long as h is not 0, h divided by h is just 1, and we're taking the limit as h goes to 0, so that's not going to happen. And when we plug everything in here, all of this stuff back here still has h's in it, and so it is all going to go to 0, and the only thing that I'm going to have left remaining is the n times x to the n minus 1, which is exactly what it was that I was looking for.